finished installing the VELO, which is the VErtex LOcator of the LHCb experiment. And this requires an incredible preparation. The detector arrives at CERN, we prepare it on the surface area at LHCb. Then it's packed into a special tank which will protect it while it's lowered 100 meters down the shaft into the experiment. It's winched over onto the platform, and then it's lifted out of its protective bath, and it has to be carefully rotated, placed onto rails, and then it's pushed into its final position. And while we're doing this, the very, very delicate sensing tip of the detector is completely exposed. And so we have to be precise to a fraction of a millimeter, and we have to be sure that everything is safe. This is a great moment for the whole team, and it's also a very scary moment because we know how delicate things are, and we're manipulating something which is 800 kilograms, and yet we know that the slightest touch on the surface of the sensors can destroy them. The VErtex LOcator recreates the traces of the particles from LHC collisions. And to do this, we have to get really close. We have to get so close that we can really peer at the collision point itself. We're just 3 millimeters away from the colliding LHC beams. And in order to get so close, we have to get inside the vacuum of the LHC beam pipe. And this is one thing that makes our detector so incredibly special. And another thing that makes it just so incredibly exciting is the technology which is inside the VELO. It's a pixel detector, and so this means that we have millions of tiny pixels. They're just 55 by 55 micrometers. And with these, we can recreate the traces of the particles, and we do this at incredible speed. So 40 million times per second, we're taking the complete picture of the LHC collision, and we're writing it to the LHCb trigger. And in order to make this work, not only do we have to have this advanced detector inside, but we need an advanced cooling system. And what we do is that we run liquid carbon dioxide into the detector, and we make it boil and bubble underneath the electronics components. And in this way, we can keep it at a temperature of close to minus 40 degrees. And it enables us to survive the intense radiation that is coming from the collisions of the LHC beams. And this is an incredible moment because it really marks the end of a 15-year cycle of development and construction. And we're very excited as that it's the last piece of this detector to go in before the start of run 3.